Hello all. Today I am going to be doing a quick guide for Mountains Map Premium version 8.2. The first thing you might notice is that this is different from the one you see in the lab. That's because at the moment I am at home over Christmas break, and this is the at home version, not the one we have in the lab. So that might be why a few things are different. Most of them are just visual. They almost always work the same ways, just look a bit different. There is a bit of a difference with area scale, but we'll get to that when we get there. So, the first thing we'll do is load a studyable. As I mentioned, at the moment, I'm not at school, so I'm not in the lab, so I don't have any surfaces I'm working on. If I did, I would plug in a flash drive into my computer, the computer I'm using, with my surfaces, and I would navigate to this PC, go down to my flash drive, and select the surface I want to use. But at the moment, I don't have that, so I'm just going to go with Coin HK. It'll load in with a bunch of different stuff, way too much than I need, or than I will get when I actually load in a surface. So, bring this up here to the front. Today I'm going to go over a few things. Mostly what I find most important and how you can figure out or learn more about any of the options you found here on Mountains. So, Mountains breaks down into two major components: operators and studies. Operators are for image touch-ups. These allow you to edit the image, things like changing your max and min, or filling in holes along the surface. Anything like that is found in operators. Studies is the other major option, and these are where you'll find analysis tools. Things like creating a 3D view or area scale are all found under studies. So, first thing I'll do is go over operators. Please keep in mind that all of this is mentioned already in the guide. I will link that in the description. That's a PDF that you can go through, and it mentions and gives a quick in-depth on everything that I'm going to go over today. So, operators. The first thing here is fill NM points, fill non-measured points. This will fill in any holes we have along the surface. I'm not going to use it right now, but no, this is really useful, especially for taking pictures of surfaces. Next is threshold. Threshold is really good if you have an outlier that absolutely skews all of the other data. And let's say it was this big line down here at the bottom, right here. This is just some absolute outlier. And when you have something like that, the best way to identify it is if you can't see the whole rainbow on your surface. If, let's say, it's all just blue, there's no red, there's no yellow, it's all blue, that'll usually mean that you have a point that is way too high. And to counteract that, you'll just come over here, slide this bar down a little bit, just a tiny bit, just to cut off that point that's way too high. Another good thing to do if you have an outlier like that is to use the Remove Outliers tool. It's not going to work right now because we don't have any outliers. This is a pre-made surface. But what this tool does is it lets you set the maximum slope, and most of the time our outliers will be literally straight up points. And I'll put in maybe 85 degrees. And what that'll do is it'll remove any point that goes higher than 85 degrees. All right, anytime there's a slope higher than 85 degrees, it'll cut it. So that's really good if your measurement has a bunch of outliers, which is actually pretty common. A lot of times you'll pull them get your surface, and it'll have spikes all over it, and that is the tool you want to use to get rid of those spikes. Moving on to remove form removal. This is really good if you were to take a measurement of something like a cylinder, something where obviously on a cylinder the left and the right side are always going to be lower than the middle. That's just the nature of a cylinder. It'll happen 10 out of 10 times no matter what you do. And that just absolutely skews the height map here. And to fix that, form removal will account for that and make it all just one flat surface so you can actually analyze it correctly. So that's really important to use. Come over here to the extract section. We have extract area. What this does is it's like a little cropping tool. Got to make sure I reselect the measurement I want to use the tool on. Something I just did by accident. And so this will let us to focus in on one area of the surface. Like let's say I want to look at the lotus here. And this will just look at the highs and lows of the lotus in the middle, not accounting for anything along the sides. So with that being said, the next thing is extract profile. This tool gets a lot of use in the lab. It allows us to draw a line from one point of the surface to another. And as we go along this line, it'll show us what the surface looks like with its ups and downs. This has a lot of use when we're using it on edges, things like ski blades or knives. If we want to look right down the edge there, this is the tool we'll use because it's very specific, very tuned, and a good measurement to use. Before I move on, I want to show you how you can learn more about any of the tools here. So there are two major ways. The first one is you can just hover over it. This will give you a few bullet points about the tool, what it's used for, nothing too in-depth, kind of like a little refresher. But if you wanted to learn more about it, you can come here to help and then use the reference guide. Let's see, what was it we were just using? We were using detect structures. We'll come here to help, reference guide. Click on search and type in detect structures. And right here, click on it. And this will give us a bunch of information about detect structures, everything you'll ever need to know about it. Easy peasy. You can do this for anything you'll find here on mountains, whether it's an operator, a study, a result, mini doc, anything. If you want to know more, go to help, type it into the reference document, and you'll get everything you need to know. All right. That wraps up operators. Again, if you want to know anything, do what I just mentioned. Now moving on to studies. Studies are our analysis tools. They allow us to learn more from the measurement and compare them against each other. So over here on the left, we have visualization. This allows us to look at our measurement a bit differently. Most important is going to be the 3D view. This is what we saw on the microscope relayed here once again. This is something I have included this every time I use mountains. It's really good to have, really important. But on from that, we have our parameters table. Again, this is something I always include. I just use the basic height parameters. And okay, and it'll create a little table here with your parameters. If you want to learn more about what each one of these parameters do, I have linked the video I already made in the description. So check that out if you want to learn more. That's really important to know what all of those mean. But On from that, we have the structural analysis. The most important one in here is going to be fractal analysis. This is how we get our area scale. As I mentioned previously, this is different than what you'll see in the lab. In the lab, you're going to want to follow the guide below, and that goes into depth, step by step, everything you need to do and what it means. So, looking here at our fractal analysis, it does things a bit different. It has two different ways of measuring it with boxes, and then it also has a volume scale. Again, to learn more, check out the help section. I'm not going to go too deep on it. I just want to show you guys everything today. But here on studies, those are the most important three things you need to know: is your 3D view, your parameters table, and your fractal analysis. That'll let you compare and contrast surfaces all day and all night. If you want to do any more, check out structural analysis. Look into these and in the help section. I don't really worry about frequency analysis or functional and identity. We don't really use that too much in the lab. But over here on the right is the workflow. The workflow is really useful and really important for keeping track of what you're working on. So how it works is you'll start here at the top with our coin HK. Then, as it goes lower and lower, things kind of start to branch off from it. So we have our color view of the surface, our 3D view of the surface, and our parameters table. All of these can be tracked back to the original coin HK, along with our fractal analysis and remove outliers. So the workflow gets its use when your page is cluttered, when it's full, because when you're using mountains for real, sometimes you can have 6-7 pages full of this kind of information, and it's really easy to get things mixed up. I'll show you an example when it could be really useful. Come over here to copper. Again, I don't have my actual measurements, so I'm just gonna get rid of everything in here. But here we have the copper, and I'll select it unless I want to make a 3D view of it. Alright, this 3D view looks good, but it's not what I wanted. I want to make a threshold of it. I'll throw the threshold all the way down here. I'm just looking at some specific points. I'll take this, and I decide I want another 3D view. So here's my new 3D view, only featuring my mountains on it. Just what I was looking for. So, as you can tell, these are now separate. This 3D view comes from this color view, and this 3D view comes from this color view. This is all kept track of here in the workflow because we have our original color view, and that'll track down to this 3D view right here. And then there's a separate section for when the threshold is done. We have our new color view, and then its related 3D view right here. Zoomed in for whatever reason. I don't know. But that's how the workflow works. It will keep things separate. It'll organize everything for you so you can backtrack, see what's related to what. Sadly, mountains doesn't label on the document itself. That's why you need to use the workflow to keep track of your work. But with that being said, that is just about everything you need to know for mountains. When you're looking to save your document, there are two different ways you can do it. You can save the document as usually a PDF. This will save everything on your paper right now, kind of like if it were a Word document. It'll print all this out for you as is. You can't come back in and edit it. And so that's good for like printing out a paper or something. But if you did want to come back into this and edit again, like let's say you didn't finish it, you're coming back tomorrow, you'll just save the document and that'll save this as a mountains file. That way you can come back to it again and work on it. And that is it for the guide today. Most important things to keep track of if you wanted to learn more about any tools, hover over it for a quick description, use the help and reference guide for more information. And there is a guide in the description below that goes over most of the things I covered today. And it's all in a PDF, just quick words. If you need to see something short, that's where I suggest to go. Thank you all for watching. My name has been Connor Cumming, and I hope you enjoyed. Thank you.